Okay, we read the problem first. Rick Wing, salesperson for Web Soldering System Inc. or WSSI, has provided you with a proposal for improving the temperature control on your present machine. The machine uses a hot air knife to cleanly remove excess solder from printed circuit boards. This is a great concept, but the hot air temperature control lacks reliability. According to Wing, engineers at WSSI have improved the reliability of the critical temperature controls. The new system still has the 4 sensitive integrated circuits controlling the temperature, but the new machine has a backup for each. Okay, and then the 4 integrated circuits have reliabilities of 0.9, 0.92, 0.94, and 0.96 respectively. And the 4 backup circuits all have a reliability of 0.9. What's the reliability of the new temperature control? So, as we read before, here we have 4 integrated circuits. So it means that those circuits is in series form, and each of them has this reliability respectively. So this is the first one, second one, third, and fourth one. Okay, so we name it as R1, R2, R3, and R4. Okay, and this is each of them, each their reliability, and each of them has backup or redundancy, and all the redundancy has the number of reliability of 0.9. So the form of the system is become like this. R1, R2, R3, and R4 is the main circuit, and then each of them has redundancy or backup, and R5 is the redundancy for R1, R6 is the redundancy for R2, R7 is the redundancy for R3, and R8 is the redundancy for R4. And what's the reliability for the overall system? Just like before, we have to work on the smallest part first. We have to work on we have 4, we could say that we have 4 circuits, right? And then 4 main circuits, and each of them has their own redundancy. So we have to combine each main circuits with their own redundancy or backup. So for R1 and R5, we call it as RT1. Okay, the reliability of these two, we call it as RT1, and the combination of R2 and its redundancy, which is R6, we call it as RT2. Also, the R3 combined with R7, we call it as RT3, and the last one is R4 combined with R8 as its redundancy or backup, we called it as RT4. Okay, so each of them is in a parallel form, right? So to find the reliability, we have to use this kind of formula, or maybe you want to use this one. It's all up to you, because at the end the result will be the same. Like this one, this is the probability of the first components, which is this one is RT1, because this is RT1, so the first component is R1 with its reliability is 0.9, and then plus the backup's probability, which is R5 with 0.9, times the probability of this one, probability of the first fails, which is 0.9. So we have to decrease 1 with 0.9, and it becomes 0.1, and we get 0.99. Or you want to use this formula instead. They result the same. And for RT2 is the combination of R2 and R6. The reliability is 1 minus 1 minus the first the probability of the first component, which is R2, and then times 1 minus the probability of the backup or redundancy, which is R6, and then we get 0.992. Oh yeah, I have not told you before, you have to work on this first, this probability times this, and the result will be used to decrease 1. So 1 minus this result. And finally, we have 0.992 for RT2, and RT3 is the combination of R3 and R7. We use this number and this number. 1 minus 1 minus 0.94 for ini R3. Also times 1 minus 0.9 R7. And the result is 0.994 for RT3, or the combination of R3 and R7. And the last one is combination of R4 and R8. 1 minus the probability of the first component, and then times 1 minus the probability of the redundancy. Okay, and finally we get 0.996 for RT4, or this combination. And finally, those RT1, RT2, and RT3, also RT4, are in a series form. And finally, we could count for the reliability for the overall system by using the formula for series form. And it means we just have to multiply this number. So 0.99 times 0.992 times 0.994 times 0.996. And finally, we get 0.9723 as the final reliability for the overall system, or we called it as RT5. Okay, so that's for the problem 4. We read the problem first. Tiger Island Fabricators, which builds offshore oil platforms, has been experiencing problems with its profiling machine, a computer-driven device that cuts the end of pipe so that it can be welded to another pipe, as shown in the data below. Okay, so here in this table we have the data about the number of breakdowns and breakdown frequency. So when the number of breakdowns is 0, the frequency is 2 times, and when the number of breakdowns is 1, its frequency is 2 times, and so on and so on. Okay, and each time a machine breaks down, the company loses about $3,000. If the company implements preventive maintenance, it will be able to reduce the number of breakdowns to 1 per month. Preventive maintenance cost would be $5,000 a month, and the question is preventive maintenance a cost-effective option? Okay, so here already known the cost of breakdown per unit, and also preventive maintenance cost per month. And to answer the question, we have to make this table first. Okay, it consists of number of breakdown, and then frequency column, probability or corresponding frequency, and also expected number of breakdowns. Okay, for number of breakdown and the frequency as already given in the problem in this table, right? Number of breakdown is from 0 till 5, and the frequency is 2, 2, 2, 6, 7, 1 respectively, and the total of the frequency is 20. And finally, we could find the probability for each number of breakdown. So for the number of breakdown 0, the probability is 2 divided with the total of the frequency, which is 20. Right? So its probability is 0.1. And for the number of breakdown 1, the probability is 2 divided with 20, and it becomes 0.12. And also this one, because the frequency is still the same. And for this one, when the number of breakdown is 3, the frequency is 6, and the total of the frequency is 20. So the probability for the number of breakdown 3 is 0.3. And you just have to repeat the steps for the rest of the number of breakdown for its probability. And finally, we could count for the expected number of breakdown. Okay, to find the expected number of breakdowns, we could use this formula. So you have to multiply the number of breakdowns with the corresponding frequency or the probability, and then you have to sum all of them. Okay, so you have to multiply this column with this column, okay, the number of breakdown with the probability, and then you have to add all of them. So the first one is 0 multiplied with 0.1 plus 1 multiplied with 0.1 plus 2 multiplied with 0.1 plus 3 multiplied with 0.3 plus 4 multiplied with 0.35, and the last one is added with 5 multiplied with 0.05. Or I made a column here, expected number of breakdowns for each of them. But actually when you write it in the paper, so it's all up to you whether you wanna make a table like this or you just write it in the line. Here I make a table since I use Excel. Okay, 0 is the result for 0 multiplied with 0.1, and 0.1 is result for 1 times this one, and so on and so on. You could see the formula for all of this in this box, right? So for expected number of breakdowns, again, you just have to multiply the number of breakdown with its probability, and you have to sum all of them, then you find the expected number of breakdown, and the total is 2.85. okay, it's equals with this one. We get this number by add or sum all of these numbers. Okay, and now we have to calculate for the expected breakdown cost. We know that the cost for breakdown per unit is $3,000, and we get it by the expected breakdown cost. We get it by multiplying the expected number of breakdown, since it's the number of breakdown, with the cost per unit, which is 3,000. So the expected breakdown cost is $8,550 per month. Okay, we get it by multiplying this number with this number. Okay, and now we count for preventive maintenance costs. For this one, we know that the maintenance cost per month is $5,000, and for this one we get it by adding this two kind of costs. Okay, cost of breakdown per unit plus preventive maintenance cost, and then times 1. Because why times 1? Because we count it for per month, for 1 month. And finally we have 8,000 for our preventive maintenance cost. And to answer the question, is preventive maintenance a cost-effective option, we have to compare between these two costs. And since preventive maintenance cost is lower than the expected breakdown cost, so preventive maintenance is a more cost-effective option. Therefore, it's suggested to implement preventive maintenance. Okay, because the reason is this cost is lower than this one. Okay, so that's for problem 5. Okay, next and the last one is problem 6. The story is, in the last year, PT Surya Mas Jaya has implemented autonomous maintenance as preventive maintenance for their production machinery. They used this strategy because the cost to repair each broken down machine to working condition is 20 million rupiah. The cost for autonomous maintenance is 5 million rupiah per month. However, they observed that in the last year, the breakdowns still happened, but at a lower rate than before the implementation of preventive maintenance. The breakdown rate is presented in the following table. Okay, so we in this table we have number of breakdowns, also number month. Number of breakdowns is 0, 1, 2, 3, and 4, and number month is 5, 3, 2, 1, and 1. So for the number of breakdown 0, there is 5 months. For number of breakdowns 1, there is 3 months, and so on and so on. Their business partner offers new preventive maintenance service to cover all repair and preventive activities. They offer at 35 million rupiah per month. And the questions are: A. Explain briefly with an example the concept of autonomous maintenance that has been implemented by PT Surya Mas Jaya. And point B, should PT Surya Mas Jaya accept the offer for new preventive maintenance service from their business partner, or should they just implement their current preventive maintenance? And the last one is, besides the cost, what are the other factors that should be considered in determine the preventive maintenance program? So we are given about the cost of breakdown per unit, which is 20 million rupiah, and then cost for autonomous maintenance 5 million. Also preventive maintenance service cost, which is 35 million. For point A, we have to explain briefly about the autonomous maintenance. So basically, autonomous maintenance is operator's partner with maintenance personnel to observe, check, adjust, clean, and notify. And for related to this theory, you could look at your book. Here, I screenshotted a bit about autonomous maintenance, and for the rest of it, you could refer to the book. And then move to point B. Should PT Surya Mas Jaya accept the offer for new preventive maintenance service, or should they just implement their current preventive maintenance? So to answer that question, we have to make this table again. Okay, the number of breakdown and frequency is already given in the problem in this table. You just have to copy it here, and then you have to add one column related to probability or corresponding frequency. The step is like the previous one. You have to know the total of the frequency first, and here we have 12 as the total of frequency. And for the probability, we get it by dividing each frequency to the total of frequency. For the number of breakdown 0, the probability is 5 divided with 12, and we have this number, okay, by dividing 5 with 12. And then for the number of breakdown 1, the frequency is 3, and the probability is 3 divided with 12, and so on until the last one. And finally, we have these numbers for each probability. And for the expected number of breakdown, still we use this formula. We have to know the total of number of breakdowns multiply with corresponding frequency or the probability. So we have to know 0 multiplied with this one, plus 1 multiplied with this one, plus 2 multiplied with this one, plus 3 multiplied with this one, and plus 4 multiplied with this one. Okay, let's make the new column, expected number of breakdowns okay. For a number of breakdown 1, the expected number of breakdowns, then you get it by multiplying this number with its probability, and so does for the rest of it, and you have to sum all of them. Then you finally get the total of expected number of breakdown. Okay, like this one. And for expected breakdown cost, we get it by multiplying the cost of breakdown per unit, and then multiplied it with expected number of breakdown plus cost for autonomous maintenance. And then the total is $28.33, and it's for per month. And for the preventive maintenance cost is equals to this info given. Okay, the preventive maintenance cost is $35 million. Oh, it's supposed to be in rupiah, and it's also per month. And now we have to compare both of them between the expected breakdown cost and the preventive maintenance cost. We know that between these two, expected breakdown cost has lower cost, right, than the preventive maintenance cost. Okay, so since preventive maintenance service cost is higher than the cost of repairing the machine, the company is better off denying the preventive maintenance service over. So that's the answer for point B. And the last one, question point C. Besides the cost, what are the other factors that should be considered in determining the preventive maintenance program? Okay, so the considerations in determining preventive maintenance program include, but not limited to, first is the capabilities of the employees to do preventive maintenance, and then the second one is sufficiency of resources, and the last one is company's capabilities to train the employees to do preventive maintenance. Okay, so that's the questions, the answer for question C, and yeah, we're done answering all of the problems for this session, for our 10th session of operation management tutorial. And this is our last session, and yeah, good luck for your final exam. Please do learn from your book as well, and also the exercises that the lecturer had given to you. Please just not learn from this tutorial. Okay, so that's all. Thanks for watching all of my videos related to this tutorial. Hope you guys are doing well in your life, in your exam. Okay, thank you, bye.